Hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, space weather guy. That's what we're talking about today. We've had a ton of solar flares. There is basically a solar meltdown in progress right now from this sunspot group 4455. And this is something that I forecasted had a higher likelihood of occurring about a week ago on the 27th of May during one of my videos. I discussed the upcoming planetary geometry of early June and how this sunspot at the time was right there. We had seen prior activity from it. Planetary geometry was such as like, okay, we probably have some activity coming in, but solar activity at the time was flat, totally quiet, quiescent, nothing to be concerned about. Well, here we are. As you see, we've had a ton of activity. Specifically, if we go back to when it first started flaring, which this video, I'm not sure it shows the very first few flares. Yeah, it shows all of them. So there's two 1.2 M class flares, there's a 3.3 M class flare, a 9.3 M class flare, and then an X class flare, a 1.0 X class flare, all in about 36 hours. So we've already seen imagery from our chronograph of this racing out to Earth. I can show you that right here really quick. We're going to do a complete update. It's also more than just solar activity. We've been having some earthquakes batter off the coast of California and Oregon. That is interesting because what we see is that there is this ability for small faults and earthquakes on those faults off of main fault zones like subduction zones to influence synchronization of earthquakes on those bigger fault zones. Some research that has come out examining that with data all across the world, Japan, Cascadia, which is where this is happening, but also other locations like Chile and California and more. So we'll discuss that because this is a big deal. But here we see our chronograph for these solar storms. And you see that not all of them are Earth directed, but then we get our first one, and here's our second one, and here's our third one right there. So that's the 9.3 M class flare, the 7.7 M class flare, and the 1.0 X class flare. Really crazy stuff. And if we check out this video here, your mind may be about to be blown because this is super, super cool. A gigantic blast of plasma from the 7.7 M class flare. Thankfully, it looks like most of it's going to the north. I mean, it's unmistakable. You'll see it when it happens right there. Ho, 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 boom shakalaka. That is a big, big ejection of plasma from the sun. But in general, because of all these solar flares that have happened, this machine gun of activity over the past 36 hours, we have a mega solar storm coming in. And as of right now, all the space weather agencies are scrambling. They don't have any updates for us in terms of what they think is going to occur. That's why I'm here for you live right now. I saw the 9.3 M class flare last night right before I went to sleep. And I'm talking about the sun so often, and I've been studying this so much. I'm like, I just have a feeling we're going to get more than this. And so I went to bed without doing an update because I was like, I bet when I wake up we got some more. And well, we had the 7.7 M class flare and the 1.0 X class flare. So now I'm reporting for you, there may be more. We could have more activity coming in after this. All of these flares, honestly, just the way they've been happening, it's just kind of like, again, a machine gun. So we don't know when that's going to stop. But what happens is that these combine in space and they kind of stack together when they are launched in a rapid succession like this. And we're looking at a severe to extreme geomagnetic storm. So G4 to G5. I would be shocked if we had like anything less than a G4 storm. Who knows? Space weather forecasting is very difficult. But pretty good track record here on the channel, especially for the big momentous events like this, which is why there's some confidence here. So expect aurora, perhaps, especially depending on where you live, if you're higher latitude regions in the next 2 to 3 days. I don't know the transit times on these specifically, but if today is the third Wednesday, I think we're probably looking at something coming in at the earliest on Friday, and more likely the junction between Friday, Saturday. Depends on where you live, of course. If you're in the Philippines, it'll be Saturday. But that is going to come in and I think quickly drive activity up. So, yeah, a lot happening. And there's more than just that too. Again, we're going to kind of go through all this, but we also see here with our 211 angstrom view, our 193 filter on it, this coronal hole. And so this right now is just entering the geoeffective position. You know, it's right on the solar equator. This emits a high-speed stream of solar wind, low density. This sort of structure sweeps by the Earth and in general raises geomagnetic activity to a G1 to G2 level. For this one, G1 storming is expected, but this is also, you know, creating this high velocity, low density solar wind structure in front of these solar storms. So because of that, these storms may reach us a little sooner than they otherwise would because plasma interacts with itself in interesting ways. And so if you have a whole bunch of slow moving plasma in front of these storms, that will gunk it up, you could say, and cause it to just slowly advance or more slowly advance. If it's a huge shock wave, it can push everything. You can kind of think of like the dynamics of water, which we've all seen and we just understand intuitively, but it's not exactly water, okay? So, but it's likely to arrive a little bit sooner than it would have if the solar wind had been very, very slow. And this is about to hit us. These storms, again, about 2-3 days away from impacting us. So a lot happening. Hello and welcome, everyone. I am your host, Stefan Burns, and let us jump right into it. We'll start by looking, well, actually, let's do this really quick. I just want to let you know, by the way, that we are, I'm doing an impromptu flash sale on the website. So if you don't know, I have a website where I sell a variety of holistic wellness products. This is like all herbal organic tea blends that we make and mix ourselves. My dad and I, we keep this going. And so we have, for example, like spirituality, which is a fantastic tea blend to help you rest, relax, to sleep better, to connect to your dreams more. It's really, really powerful. It's 4 ingredients. It's passion flower, chamomile, mugwort, and purple lotus flower. Super high quality, all organic. We also have herb coffee, a big winner there. People love it. And other tea blends. We have merchandise. We have some other goodies here, like this natural bug spray is amazing, by the way. So a whole bunch of things that are on the website. And if you want to take part in this flash sale, then you can use the code BOOM, all one word, BOOM, at checkout for 10% off. I don't do sales often, just because we already try to offer everything at a really fair price, and we do. But we do have some room to offer sales, and well, when we got some activity like this, it's good to jump on it and add some goodies and, you know, pump things up a little bit. So boom for 10% off the website. Everything is shipped from the United States, and we ship it out pretty quick. It's all available for those in the United States. So if you're international, I'm sorry, we don't have any access for you other than the holistic gut health guide, which is, you know, 90% of people have gut health problems, whether they know it or not. So you may want to pick that up. It's a good read. Wrote that a few years ago. So I just wanted to let you know about our sale at earthevolution.com/store. Here we have our X-ray flux, okay? And here is a comment from one of our viewers. She's been watching for a long time. She loves the hoodie. Yeah, the hoodie's awesome. Okay, so here is our X-ray flux going back for the past 7 days. And if I turn myself off really quick, you will notice that it is totally quiet going from the 28th of May to the 29th, the 30th, the 31st. But starting on the 2nd of June, things immediately ramped back up in activity to M-class activity and then also X-class activity. So we see right here the two 1.2 M-class flares, boom. Here is our 3.3 M-class flare. And then we see our 9.3 M-class flare, our 7.7 M-class flare, and our 1.0 X-class flare. So I definitely could see us having more of these. All these being very brief, like very quick solar flares, as you can see. just quickly spiking up this EUV and X-ray flux. These are light photons that are being produced. So they hit Earth 8.3 minutes later. In fact, when we observe these is when they're hitting us, right? It's not like that we see it with our telescope and then it hits us 8.3 minutes later, because when it hits the telescope is when it's hitting us, because that's how light works. So the moment we observe these is when they're hitting Earth, and that charges up the ionosphere, the global electric circuit. The entire Earth really gets going, gets charged up. That's happening right now. And in this forecast that I put out about, 7 days ago or so? Yeah, it was the 27th of May. I talked exactly about this. So let me show you that really quick. This is pretty cool. We're gonna put myself on stage. This is a clip from my video on the 27th of May. It's just like in 90 seconds or so. But this really shows you that you can use planetary geometry to forecast space weather and solar activity, because a week ago, no one was forecasting that this is going to happen. I mean, maybe some people saw that sunspot and were like, maybe we get something, but here's the thing. There are, SpaceX, for example, has 10,000 Starlinks up in orbit now, right? There are huge industries that have satellites in space. They have assets in space worth billions of dollars. And well, if you have billions of dollars of assets that millions of people rely on the ground, you want results. You want what's actually going to give you the heads up. And so anyone that is just like belligerent about certain things is not going to be on top of it. And we see time and time again that planetary geometry is a useful indicator of space weather, because there is a connection between the sun and the planets. This work goes all the way back to the beginning with J.H. Nelson, with RCA in the 40s, 50s, 60s. So this isn't new. But for some reason, because there's this connection with the planets, people immediately think astrology, and there's this mental block with astrology, and so people just like, so they don't use it. But hey, when you got billions in orbit, and soon it's gonna be trillions of dollars worth of money, you don't care about, false belief systems or anything. You care about results. And so here we see some results. Let's check it out. 1st of June is here's the Earth. We see it's in opposition to Uranus in Ceres. Almost perfect, but not exact, but still with this opposition. Then it has this square there to Mercury and Venus, and they are also square to Uranus and Ceres. So Mercury is seen as the activator of heliocentric planetary geometry. It's swinging in, it's activating Venus there, and also triggering this square to both Uranus and the Earth. So Earth is part of this critical planetary geometry. And not only is it part of this square and opposition configuration, it's also then taking part in this basket configuration, because it has this trine over not only to Saturn and Neptune, but also to Mars and Eris. So it's participating in all of that. So it looks like, well, at least we have the background configuration set up for there to be some significant solar activity and or space weather right around this time frame, when we have this sunspot here going to be in that strike zone. We don't know how it's going to evolve or grow or flare or anything through that period of time, but that's making it look more likely. So that's the short-term forecast. All this solar activity, let's say we get it, I think we will charge up the ionosphere, the global electric circuit, all this. That's it, folks. So I do have a long-range planetary geometry space weather forecast for the end of July, beginning of August, because we have some pretty nice planetary geometry, heliocentric, by the way. It's all heliocentric for August 1st. So I think we could see some activity then. Here's that sunspot I was referencing at the end, 4455. And sometimes, as I talked about in that video, we get these sunspots with these single big cores to really be explosive. And since it actually rotated, we see that a little bit of flux is pushed out around the sides of it, but in general, it's still just one large core. But that was back on the 27th. I issued that forecast. Good to stay open-minded about all these things, because results is what matter, at least in my mind. And so today is the 3rd of June. Here we see our heliocentric planetary geometry. We're probably going to get some activity all summer. The reason why is we have a preset configuration with the outer planets. And if you read J.H. Nelson's work, specifically his book Cosmic Patterns, you'll notice that he had a lot of his example charts of like 1960 or 1940, because that's when you had a preset Saturn-Jupiter conjunction, because they happen every 20 years. So 1940, 1960, 1980, 2000, 2020, they have a 20-year cycle. So every 20 years you get this natural config where Jupiter and Saturn are aligned, and that in general seems to enhance things. But here, instead of that, we have this basket configuration. So you have Pluto sextile to Neptune and Saturn. We have the two of them sextile to Uranus. And we have Uranus sextile to Jupiter, Jupiter in opposition to Pluto, and then that means Jupiter is trine to Saturn and Neptune, and Pluto is trine to Uranus. So this is a very rare planetary geometry. People have gone back and looked, and we can't find something like this in the recent record of thousands of years. So what exactly this entails energetically is kind of unknown, but that's the preset configuration. The planetary geometry that I specifically was mentioning was here with Mercury and Venus, both in alignment with the sun. We'll check out solar system scope. Them coming in and forming this square to the Earth and the Moon, which is in opposition to Uranus. Now that was specifically just a couple days ago. If we go back, we see it really click into play on the 1st of June, and you'll keep in mind that this clicked into place on the 1st of June, and then just the next day, Universal Time, June 2nd, is when we started to get all this activity. So now that the sun has been woken up, you could say, it's happening. And again, here we see our activity, 2 1.2 M-class flares, 3.3, 9.3, 7.7, 1.0, and probably more. Hard to say, but probably more. I don't think we're done, but we'll find out. Now, if you go to our longer view of solar activity, I just want to show you this as well, because it's not like we had X-class flares 2 weeks ago and we're just in general in a heightened period of activity. This is the strongest solar activity that we've had since the 24th of April. So you can see that right here. So we had this ramp up there in April, and we had some X-class flares, as you can see. And we talked about that when it happened, right? Now, we did have some other flares there that popped off at times, but in general, we see that things have been on this downtrend. Look at how right after June 1st, Universal Time, boom. So right after that very nice planetary geometry, we started to get this pop off. So make up your own mind, coincidence or not. I mean, we keep having these coincidences over and over and over, which tells you it's not a coincidence, that there's something to it. The alignment of the planets, how they affect the energy fields of the solar system, seems to influence not only sunspots and their specific electromagnetic dynamics, right? So like electrostatic double layers and how plasma moves around in the magnetic fields and more. We know that the planets, especially the gas giants, actually release radio waves, and they can, at all different frequencies, especially Jupiter. It's releasing megahertz, gigahertz radio waves. That has an influence over plasma. But there's also the gravitational effect, and we see that planetary resonances and even the subtle effect of gravity from the planets seems to influence the solar dynamo, which exists underneath the surface. Because you don't need big perturbations to generate, changes in the flow and convection within the sun. So there's a lot of research on this stuff. It's really, really fascinating. One of the things that's happened as a result of all this solar activity, then I'm going to touch on the earthquakes really quick because this is pretty big. But we see that Earth has been ionized a lot. So we've had tons of ionization, or effectively plasma generation of Earth's ionosphere as a result of these solar flares. So we'll start to see them really come in, and it's all happening over Eurasia, okay? All these have been happening over Eurasia. So they're going to be brief. There's one right there, and we'll get another one coming up soon. And that should be, maybe that was the last one right there. Did they? Oh, they changed this. This used to be a 24-hour product. Now it's only like a 12-hour product. So this is the 7.7 M-class flare right there. And then if you go forward all the way to our X-class flare, we see it right here. Okay, but unfortunately we can't see the others because at least at 9.3, because this is a like a half a day product now. It's not a 24-hour model that they show. But that's charging up the upper ionosphere, slamming Earth with those photons. And when you have extreme ultraviolet or X-ray light, it effectively absorbs instantly into whatever it hits. So because it's such a high frequency, it's called ionizing radiation. And so it takes whatever the element or molecule is, and it'll strip an electron off of it and combine with it. And that electron will absorb the photon, energize, become a free electron, fly around however. The other thing is now positively charged. So it starts to move in the electric field as well that exists. Though slower, electrons can move really quickly. Heavy positive ions move slowly. You get this differentiation to occur. You create plasma. And what happens eventually is that electron will then decharge a photon, perhaps at a different frequency and energy, but it can decharge a photon and then drop down in energy level and recombine. So you get this, there's a specific term for it, but you get this ability for the molecule or element to ionize, and then you get this recombination. It's always happening, and it's pretty quick. But when you get this sort of solar activity really rapidly, you're just in general keeping these free electrons more active with less like recombining with the positive ions than normal. So Earth's upper atmosphere, the ionosphere, is about 1% plasma under normal situations. And right now it's more than that because we have all this solar activity. That drives a global electric circuit. And the global electric circuit drives a lot of activity on Earth, including, for example, earthquake activity. That's where there's a lot of research. We don't have all the answers. I never claim to have all the answers, right? I'm just very open-minded. I do a ton of research. I also do thought experiments. I'm intuitive, all this. I think that's all very important if you really want to understand what's happening. But we have a classic convergence here where we had planetary geometry that was very significant, and we still have that basket of the outer planets, Pluto, Saturn, Neptune, Uranus, Jupiter. That's configured all summer. That's not going away. It's just now how do the inner planets play around with that? We have this coronal hole, we have all the solar activity, and more. Now, if we look at earthquake activity, I'll probably talk about this more later, but I want to touch on it now. We see that we've had two different zones of activity here in the area that is basically the Cascadia Subduction Zone, okay? So the actual subduction occurs right here on this boundary. This is the Juan de Fuca plate, and there's actually three plates here, like two microplates, the larger plate, but basically the Juan de Fuca plate. And if you go to the south, you have the Cocos plate. These all used to be combined. They still are to some degree under the surface because that all used to be what's known as the Farallon plate, where you had a plate subducting underneath North America, and now they are separated because you have the San Andreas Fault here cutting through California down through Baja, and that is now a transform zone. But what's interesting, this was a mid-ocean ridge, a spreading center, where you have active plate creation like this, and we still see that if we go here to the subduction zone. Well, this is a subduction zone right there. If we go just off to the west, the Juan de Fuca, we see where you have active creation of oceanic plate. You also have a large volcano here. This is axial seamount. So it's all connected together, these convection dynamics and more volcanic activity, etc. Well, what happens when you get when we see this in some other places in the globe, but this is a key zone for us having figured this out. When you get a mid-ocean ridge just subduct down, the two cancel each other out and you create a transform junction. And there was a bunch of volcanic activity in California when this happened. If you do any field work around California, you'll see all these volcanic tuffs from a few million years ago everywhere across also this part of the US from these big volcanic eruptions. And of course, Cascadia now has big volcanoes because of the subduction zone. You have Mount Hood, Mount Rainier, you have Shasta, you have, Larson? Is that it? Yeah, I've been to quite a few of those. But now that mid-ocean ridge is under California, you get this transform fault. Well, here is a 5.7 magnitude earthquake, and it's in the oceanic crust. They have it at 10 kilometers down. A lot of earthquakes do occur at that depth, but that's also the default value that they use if they can't calculate it. Now, we can look to see what was calculated here with our moment tensor plot. We see it's 11.5 kilometers down. So 10, 11, 12 kilometers down is generally where this occurred. And if we look at our moment tensor plot, we see that this was effectively a strike-slip earthquake with a little bit of extensional movement to it where the plates are basically moving apart. And we know it's mostly strike-slip where they're grinding past each other because we see our rake there is close to either 0 or 180. And that indicates movement like this. If it's 90, or negative 90, if it's positive or negative, it tells you if it's moving up or down. Then that would indicate that it's just simply reverse or extensional. And we see our fault planes, the slope for that. It's pretty steep, 85 degrees for this solution, 77 for that one. So the classic strike-slip earthquake here in the oceanic crust for the Juan de Fuca plate. And here's where this is important. Last time we had some earthquakes in this area, okay? I did a post on it and I talked about the Cascadia Subduction Zone and all these meteorologists from the Pacific Northwest, not geologists or geophysicists, it's always a meteorologist. I love them, but hey, they came out and like, you can't say it's a Cascadia Subduction Zone, whatever. They just they went full aggro. It was crazy. You think that the sun was going crazy when it happened, but it wasn't. They went full aggro. Well, I mean, basically what's been shown is that there is a big impact of small earthquakes on tectonic tremor synchronization, which occurs at subduction zones. So they specifically looked at, in this paper, and I'll link this in the video description when I'm done, okay? Fantastic read. It teaches you a lot about this from a pretty foundational level. So if you're new to this, this is a good one to read. But you have the plates grinding past each other in subduction zones. And keep in mind, this is where you get magnitude 9s. Not that frequently, but because you can get these megaquakes, magnitude 9, it's important that we understand these things to the best of our ability, because a magnitude 9 would be extremely destructive and extremely deadly. So I'm not one to say, oh, this isn't true just because I was programmed to think this or I believe it. Like, I care about people. And so if it's going to help people get a heads up, or just for us to better understand an area geologically, I'm going to really do my best to look at all different angles, okay? When you have these plates going down subducting, there are different coherent blocks that exist within them. And they can either get synchronized, think of them like oscillators and all the springs are kind of moving together, or they can get desynchronized. And what we see is that quakes that are off the main subduction zone but close by, they can desynchronize certain blocks within the overall subduction zone. Now this earthquake really this research paper here really looked at Japan because we have a huge amount of data for Japan, okay? Tons of magnitude 7s, 8s, and even the 9.1 Great Tohoku earthquake 2011 popped off, which gave us a fantastic view as to the influence of small earthquakes greater than magnitude 2 on these larger faults and therefore the bigger earthquakes that occur. You think, how does a magnitude 2 affect a magnitude 8? Well, if it's desynchronizing the overall movement of these different blocks within a subduction zone, it can have a big impact, especially if there's a whole swarm of small earthquakes, etc. Now, the overall amount of activity at Cascadia is like a tenth that of Japan. But they did look at it and they saw a statistically significant correlation between these smaller earthquakes being able to desynchronize the seismic tremor occurring at these subduction zones. So this is not me saying that, hey, we had a magnitude 5.7, Cascadia is literally about to go. It is interesting that we've had now not just the 5.7, but we see also this 5.1 here at the triple junction, plus a magnitude 4.5 and 2.8, 2.8, right? We see two zones of activity back to back. Look at the timing here. 10:53 universal time, This is 12:45 universal time, and then 13:14. It's happening right now, right? But this is clearly active, and this is when you would look to see, okay, well, because we're having these small quakes, this is going to be influencing the subduction zone, especially if they're close by. This research paper looked and they're like, oh, it can be up to 200 kilometers away. It depends on the magnitude, the distance, and everything. But the effect can range over a pretty large area. If you look here specifically, we see that the distance from the Cascadia Subduction Zone for this 5.7 is only like 60 kilometers. And of course, if you go oblique angle, 100 kilometers, 200, so it's not that far away. It's a 5.7 too, which is much larger than most of the quakes that they looked at in this paper. So this is influencing the tremor synchronization for the entire Cascadia Subduction Zone, though it did not occur in the subduction zone itself. These associated adjacent faults have a much bigger influence over these larger faults than most people realize. And anyone that tracks earthquake activity like on a daily basis learns this intuitively. Like, I already made this connection in my head because I'm tracking this stuff all the time. There are others that have done that as well. But then reading this paper is like, aha, so we do have some really excellent data supporting that observation. We have to go by observation first to figure out then, kind of guide us to, well, where can we do research to then show and highlight the actual mechanisms that exist, right? First principles. We always want to work from first principles. It's the same thing with the solar activity and the planetary geometry. You make the observations, you see that there's something there, and then from first principles, we try to figure out what it is in a scientific framework. So, pretty significant earthquake off Cascadia, and well, we could be seeing more from that. Now let's go back here to our activity from the sun, and let's look at the coronal mass ejections that have been happening and the launch of them outwards towards Earth. Unless they've just updated their space weather model, we don't have an up-to-date model for all the different ejections via NOAA. We do have some NASA space weather models, okay? But we don't have a combined model yet. They'll refresh the thing really quick right before we launch into it. But yeah, clearly a wave coming in. This is only showing 24 hours too. We also had some activity, with the 1.2, the 1.2, the 3.3. We had some stuff go off to the side. Now you'll see the 7.7 M class flare, the one that had that huge wave of plasma. I think it's I need to update this. Let's do that. To show you again, if you're jumping in again for the first time, hello and welcome. I'm your host, Stefan Burns, geologist, geophysicist, space weather guy, your cosmic bro. You'll see the 7.7 M class flare, that huge blast of plasma, mostly to the north. That guy right there, okay? Well, that shows clearly going to the north of the ecliptic plane on our coronagraph. So they have two different models that they've created. For that, there is a very weak halo signature, but then we see the 9.3 M class flare and the 1.0 X class flare. They have more clear full halo signatures. So, but when you do get, like, let's say a lot of it going to the north, right, or to the south or whatever, but then you have this other activity on like more Earth direct, it's all just creating a large zone of disturbance. And I do think there's something to, if you have a more turbulent solar wind in general over a larger area, I think the impacts to Earth are bigger. Because if everything's nice and coherent and quiet, and then you get just like a sniper shot right to Earth, it can be a big deal. But if everything over a very wide area is turbulent, and then you get some direct waves of plasma from the sun sent to Earth, it's going to hit, like, impact even more. And that's another one of these observations, just watching this over time. So I don't ever look at like a coronal mass ejection like that going to north and say, oh, it's not going to affect us at all. People also feel these things the moment it happens. Of course, the light flux, proton flux, things of this nature. But that is just creating disturbance to the north. We had some far side stuff creating disturbance there to the east solar coordinate system, and then we get some bullseye shots, and we may have more coming in after this. So let's check out this space weather model, or these models that we have from NASA, and then we'll see if NOAA has an update for us. But let's start with our 3.3 M-class flare. This is the first one that occurred, well, after the 1.2 and the 1.2, but we see that's not that big of a deal, right? The plasma density is not that high on the 3.3, but we see it is perfectly lined up with us right there, both in our top-down view and also in our south-north view, right? This is the ecliptic plane right there. So Earth is getting hit, and that will be right around the 5th, 6th, it seems. So I think really like the boundary, the 5th and the 6th universal time, I think we have about 72 hours until we're hit. Maybe it's a little faster than that. If they really combine together and for some reason they encounter some obstacle in space, like they slow down, then more like 3 days. But again, we have this high-speed stream impact that we're waiting on. It's about to come in. Those are also connected to earthquakes, by the way. So I think it's going to arrive here a little bit sooner. So I say within 3 days or less is we have that coming in. Now here's our 7.7, and this is a model for the full halo. Now it wasn't that obvious, right? The majority of the plasma, or what we call the bulk of the plasma, went to the north, okay? But they did model that halo signature, the shock wave, you could say, from that explosion, and that shows, again, a direct impact. Now, they show this being pretty severe. I don't think it's going to, this is maybe a little bit too severe looking, considering it's just like a shock wave impact and not like the bulk of the plasma. But we do see that coming in right around the same time, right? The 6th of June. Here we see the space weather model for the bulk of the plasma, that big blast that went up to the north. You don't see it show up here at all in our top-down view because this is showing the ecliptic plane. Here, though, with our south-north view, we do see it going to the north. But look at how that in general is creating more disturbance here, right? So like this does affect us. And then we look at our 9.3 M-class flare. This is the one model that they have for it. This is a pretty bang-on blast right there. There's Earth, of course, and so slightly going to the west solar coordinate system, but we're still pretty much right there in the line of fire. And as it relates to the vertical, we see that it's also perfectly going out along the ecliptic plane. So that's all happening. And if we go here really quick, we can update this just to see if they've created a model. NASA has created a model for the 1.0 X-class flare. And it looks like they're still working on all of them. So they're working on an analysis of the faint partial halo shock, analysis of the two-load bulk of the CME, and a remeasurement of things. So they're still working. NASA is typically, they're the fastest. Okay, so here we have our latest coronal mass ejection space weather model provided by NOAA. They're showing 2 big coronal mass ejections launch out. I don't think they've accounted for the third one, perhaps. I wish they gave an update on this in terms of like which ones they modeled, but to start, this is sufficient for sure. Boom, boom, and there we see it right there. And actually that third one may be in there from the 7.7 M-class flare, but it wouldn't show up here. So let's see if we get 3 waves here, because again, it was mostly to the north. So let's check that out. It may only show up on this view. 1, yeah, there it is. Okay, boom, exactly. So they have modeled the 3 big events, the 9.3 M-class flare, the 7.7 M-class flare, and the 1.0 X-class flare. They are on top of it. I love it. Sometimes they're way behind. Sometimes they're on top of it, like right now. That's great. This is a big moment. This is like pretty significant, okay? This is severe to extreme geomagnetic activity that we have coming in. This affects satellites, GPS communication. It'll increase the drag on satellites. Radio cellular communication all gets affected. Power grids can get affected. They're much more hardened than they were like 30, 40 years ago. Somehow, even though the power grids in the United States and some places are failing, somehow they've done a better job at optimizing them. And, you know, it's kind of a, I'm not an expert on this, but it seems that some good hardening has been done because we have been hit with some pretty big impacts that did not cause big power failures, but it can happen at any time. And right now we're in the largest oil shock since the 70s. And power shock and energy shock since the 70s. So how does that affect things? Keep that in mind. Anyways, we see this coming in. There we go. See us coming in, spiking plasma density up to 50, spiking our velocity up to nearly 1,200 kilometers per second. These are fast, I know that. So maybe we're even looking more so, they're showing this model as we have like 48 hours, basically. Actually only 36 hours according to them. I think this is a little too fast, but we'll find out. Let me pause this, let me zoom in right there. They're showing peak impact in about 36 hours. So maybe it's more like a 48 hour instead of 72. And I would, just based off of the velocity of these, I would agree with that. But initially, early on, you kind of always want to be a little cautious. A lot of times, forecast comes out, it's too fast, it's too soon, and then it's like 2 days later it hits, and everyone's forgot about it at that point, and they think it's not going to happen, and then we get rocked. So anytime from the 5th to the 6th is really that key window for when this hits us. This is a big, big impact. I think we're going to be seeing G1 to G2 activity as a result of this, or sorry, G4 to G5 activity as a result of this. We can go to our forecast discussion. I don't think they'll have updated it, but perhaps, yeah. So they're still just talking about the stuff that we have from the coronal hole high-speed stream G1 storming, though they do talk about the filaments and other things as well in here. But they don't give an update, and they won't until it is, it's 12:30 a.m. Universal Time on the 4th. So we have a little bit of time until NOAA issues their official update on what's coming in, but we see the space weather model G4, G5 activity is coming in. So first you get the charging of the global electric circuit, then you get the big impact, Earth's magnetic field crunches, and you get this huge geomagnetic storm where you get swings in the field strength and things really get going wild. We see that our proton flux is flat, so there hasn't been some huge release of high energy protons from any of these explosions. Typically you need like a really strong, really long duration solar flare to do that, where you get these protons to get accelerated into shockwave in advance. We're not seeing that, so that's good. If that was the case, Earth would be charging up even more. It would be an even stronger impact. It's not like we've never seen impacts like this before, but it's certainly out of the blue. Again, we were forecasting enhanced space weather activity around the 1st of June, and there's usually like a day or two on either side. Well, now we've had the solar activity, and the solar storms are coming in. We look at our ACE real-time solar wind right here, go to our 3-day view, and we don't see them rising up yet. These will go up as the solar storm gets close in, because as that plasma wave is coming, it's also accelerating some electrons and protons in the front of it that then race out a little bit faster than the plasma itself, because the plasma is not moving that fast. Again, their model's showing like nearly 1,200 kilometers per second. Well, speed of light is 300,000 kilometers per second, and particles can get very close to the speed of light. This is relativistic flux, that's what it's called. So they can get there, they can start to move really quick. And a proton, to move close to the speed of light, it has a lot of mass, folks, compared to an electron. So for it to get sped up that high means that it really has a lot of energy, and one single proton impact in our upper atmosphere, the ionosphere, can trigger a particle cascade of ionization across thousands and thousands of particles. So it has this chain reaction effect, and they can pierce deeper into the atmosphere too, charging up deeper layers, which typically aren't ionized, okay? So Earth's upper atmosphere is ionized. We can put on their model for the ionosphere, by the way, our GlowTech model. Here we have it. So Earth's upper atmosphere is ionized, about 1% plasma, and where we live, the troposphere, there's no ionization, okay? There's no ionization. The density is much higher though. Here's the thing. A lot of people haven't thought of this. The density in the ionosphere is way less than the density in the troposphere. There's at least 50 kilometers in between them. The lowest layer of the ionosphere is the D region, about 50 kilometers up, 100 kilometers up at night. But the majority of plasma in the ionosphere is about 200, 300, 400 kilometers up in the F1, F2 layers. That's where it gets charged up. But you'll get these lower layers to charge up too as this particle flux comes in and really gets deeper and deeper. If you were to have, let's say, like a super flare impact, and this is not that, okay? But if you were to have a super flare impact, that would charge up the lowermost levels of the atmosphere. It would definitely hit the stratosphere. It would start to hit the troposphere, I'd imagine. And now you're getting ionization in these layers, which are typically very resistive and just gas. There's really no plasma like we typically think of, okay? There's always plasma, but not like the ionosphere. But you have the highest density in the troposphere, way higher. So you have the ability for there to be a much thicker, stronger plasma in the troposphere should you be able to ionize it. And well, this isn't going to do that, but the point is that the bigger flares that you have, the stronger the impacts, the more relativistic particle flux, the deeper it can penetrate in. Because once plasma has been plasmified, it's effectively transparent to future and incoming radiation because it's already ionized. And so that will pierce through the plasma and then reach those deeper levels that are unionized. So this is that global electric circuit charging that I've been talking about, and it's important to look at this from the earthquake perspective because because obviously earthquakes are connected to all of this. And well, we're seeing now, right as these flares go crazy, we're seeing activity in the Juan de Fuca plate, right in the Cascadia Subduction Zone. And personally, I just call this entire area the Cascadia Subduction Zone because as we just looked at with this research paper, there's an impact on small quakes on tectonic tremor synchronization. And so this whole thing is connected together, okay? Be foolish to think otherwise. But this one right there, not occurring on the rifting zone, by the way, or the transform, like it's right just 60 kilometers off from the subduction zone itself. And then this triple point there obviously is right on it because this is where you have the San Andreas meet the subduction zone itself. That is where you have that, that boundary. And we have that also to the north here with Vancouver Island. So pretty crazy stuff. Actually, I'm not sure what island this is called. This is obviously Vancouver Island right here. The north of it, I don't know what island that is. But big activity. I'm not sure I have really anything else to mention other than we'll do a Q&A. But will this impact us severely? I'm looking G4, G5 storm. I could see us having radio communication issues. There's certainly going to be GPS issues. Consider also the fact that right now it's June 3rd. We have this coming in June 5th, June 6th. How many farmers are planting right now? Huge amount of farmers are planting right now, of course. And so they're going to be out there. They have their schedules. Their schedules. They're going to be planting regardless. Now all of a sudden, these big combines and tractors that are GPS guided, they're swerving all over the place because we got a big storm coming in. That happened back in 2024 with the Gannon storm or the Mother's Day storm, May 10th to the 12th. There was planting going on. And a lot of farmers had their things getting thrown off like crazy because it's high precision farming, all based on GPS and communication and more. So all that's going to get affected, right? We already have the biggest energy crisis since the 70s. 20% of global oil flowed through the Strait of Hormuz. A little bit has been redirected from Saudi Arabia to their other port towns on the other side. But basically all that oil is still cut off. And you have, on top of that, now impacts like this. That's also affecting fertilizer and urea and nitrogen and these sort of additives for agricultural sector. And farming and planting and growing, that's all affected. Oil prices are rising, affecting transportation. There's almost certainly going to be a food shock coming in, huge amount of inflation for your food. I would definitely recommend that you pick up like 50, 100 pounds of rice and maybe like 50 pounds of beans or something like that, some freeze-dried vegetables, and keep that on hand. I already have that. It's not that expensive. You'll actually save money because it's bulk. But definitely it's good to have just like some good, healthy, decent survival food on hand because it'll save money as inflation just rips higher. And then also if something really crazy happens, you're protected. It's also good to have something like a solar suitcase they have these solar panels that can fit into like this suitcase. They all fold together into like this suitcase. And it'll be like 800 watts, which is a good amount. I have 800 watts that can run a refrigerator, that can run an induction hot plate, help you cook your food, something goes wrong, right? It's good to also have like one of these solar suitcases. So if something happens, boom, you got some solar and you can start to work with things like a backup battery, like 2 kilowatt hour backup battery, 4 kilowatts better, right? A solar suitcase. You're doing okay should crazy things happen. Now, is that going to be the case for this? Probably not. I don't think that we're going to get plunged into darkness unless we see a solar flare. A super flare. If we see a super flare, all bets are off. No one knows how that's going to impact us and what it's going to do. But a super flare is 10 times at least more energy than a Carrington event. Okay, that's the modeling for it. And let me show you what a Carrington event does to our magnetosphere. We have a model of the Carrington event, an oblique view. Let's check this out. There we go. So this is a model of what happened with the Carrington event. Look at our Earth's magnetic field rapidly compressed, and you have this huge amount of plasma going right down. The magnetopause is like less than geosynchronous orbit. So all those satellites in geosynchronous orbit are being blasted by the solar storm, and our other satellites that are rotating through the daylight side, they get blasted. Obviously, a huge amount of reconnection and particle flux right here. So this is a Carrington impact, 1859, big deal. A super flare 10 times at least stronger than that. All bets are off. If a super flare happens, I'll report for you, and then we're probably never seeing each other again online. So yeah, you know that when a super flare happens, I'll say super flare is coming. But I'll let you know. But the interesting thing that I'm seeing right now, in addition to the solar activity, are these earthquakes that are occurring here, Juan de Fuca Plate, Cascadia Subduction Zone, and more. And anyone that's in this zone, I would just in general be a little bit more aware of that. I don't think magnitude 9 is imminent, though the last one was the year 1700. So it has been 326 years. It could happen any moment. It could happen any moment. This raises like the risk percentage though, right? So if it's normally every single day is like you assign it a risk chance. If it's normally 0.001%, maybe it's now 0.1%, something like that. Like a 10x jump, but still overall absolute scale, very, very minor. So just keep that in mind. So let's jump over to a question and answer. And if you have any questions, you can ask them. I'll take some from the general chat as well as any that came in with super thanks. I see some came in here as super thanks, so thank you everyone. Maddie Tempo, thank you for the 20 memberships that you gifted. Boom shakalaka, that is super, super generous of you. Maddie, by the way, he posts updates on Schumann resonances, solar activity, earthquakes, and more on his X account. I don't know exactly how active he is, but I have seen some of those updates pop up. So he's another person to check out on X. I think you just type his name in to see it. Just tuned in, can I get a recap? You can watch the video once it's done, or you can scroll back in time. You're probably up to date now though. Heather, thank you for the super thanks. Very generous of you, much appreciated. Stacy, thank you for these super thanks. Yeah, touch grass, that's the big thing. Touch the grass, go outside, do your earthing and grounding. You wanna regulate your own bioelectric system as well, okay? So when these events happen, they charge up everything. And we are in resonance with the earth, we're in resonance with the sun, we're in resonance with the cosmos, right? Because we are literally made up of all these things. We are, the earth has a certain accumulation of matter that has, over time, that we are born of, right? Your mom gets pregnant and you're a single cell, and somehow that single cell becomes a baby. How does that happen? Well, she's eating food, and it's synthesizing into new cellular production. So we owe everything that we have, other than our consciousness and maybe a little bit of bioplasma, to the Earth. Well, where did the Earth get it from? It got it from the stars and past supernova explosions and more, which is all the cosmos. So we fundamentally have this built-in resonance that's beyond eons old, right? It's just fundamental from the beginning. So yeah, when these things happen, get charged up. find a way to move that energy and also make sure find a way to balance and ground your system. And generally, going outside, touching some grass with your bare feet is the best way to do it, but also going on walks, moving, exercising, drinking lots of water, deep breathing exercises, all this super, super important for that. So thank you, Stacy, for the super thanks. Thank you for the super thanks as well, Adam. Usually red flag for disclosure type content creators who monetize, not with Stefan. His clean intent overcomes the low coherence trap. Thank you for your work. Yeah, I mean, I make money with YouTube, sure. I mean, everyone deserves to have food and like roof over their heads and, you know, maybe a little bit of abundance. I don't think it's a bad thing, especially when the mega billionaires have like 99% of the wealth, okay? But yeah, this is really, I just find this stuff super fascinating. I want to educate everybody on this, keep you guys aware of what's happening. That is my intention and goal. Everything else is just a perk. Dark Cloud, so thank you for that super thanks. Dark Cloud, yeah, the Barbeau basket. It's one phrase you can use for that configuration of planets. Barbeau identified that and talked about this. He's an astrologer. And other calendars like Julian, not just Gregorian, what are your thoughts? I'm not sure what you mean. Like, yeah, I have no idea what you're talking about. My thoughts on what? But thank you for the super thanks. Maybe you'll get back to us. Adam joined as a member. Planets are atoms, upper strata. Yeah, you can start to think of things in like a fractal scale. Stars could be atoms, right? If you really zoom it out, then things get interesting. You can even consider like the flashes of light from a star as being the firing of neurons in the brain. Because for light, it's all relativistic. So there's no time that exists for light as it moves through space. It's just, it immediately gets emitted and immediately absorbed from its perspective. So at the level, the dimension of light, stars are communicating each other in, you know, flashing sequences and pulses in like Morse code effectively instantaneously. Once that connection gets established, they're all in communication with each other. So that's pretty interesting. Super thanks from Adam again. Coherence, resonance, frequency, plasma, electromagnetism, wave propagation, Rydberg atoms. It was never electric universe versus gravity. It's always been multiple sides of the same coin. No coincidence, no coin incidence. Yeah, exactly. I don't know why people, it's like, they have this gravity only understanding, and then other people are like, it's just electric universe. And it's like, they're all connected together. Gravity is a much weaker force than electromagnetism, but it does operate in certain ways to then influence how the electromagnetic force propagates, you could say, like how it unfolds. So for example, the influence of the planets gravitationally on the inner solar dynamo then influences sunspot generation, the magnetic field of the sun, and that's all electromagnetic. So you see how they're connected together. It's really, really interesting. Celtic is asking people if they hear the frequency change before big events happen. She does. It's very predictable. Yeah, a lot of people feel these before it happens. I can't fully explain that, but I also think that there is a deeper, more causal layer to all this, the quantum field, and consciousness is inherent to the quantum field. And we also, if we have these galactic events that are influencing this, then if you pick up on that before it really gets going, then yeah, that's the deal. Christy is asking about her dad flying on the 4th of June. Will air travel be affected? I mean, if it's tomorrow, he should be fine. There'll probably still be solar flares, or at least that's a high likelihood, but the solar storm probably won't have hit yet. And that's the bigger deal when there's a solar storm. But planes are flying all the time during, solar flares and geomagnetic storms, so they're not crashing. Though there was a huge recall of like 6,000 planes because of how a solar flare and the ionization was able to affect the black box and like nav computer of planes. So that's always a risk. But if they're falling out of the sky like crazy, then yeah, obviously we would have some regulations in place. But having been on the plane many times, when you get big solar activity, you certainly feel it because you're totally ungrounded and you're closer up and you're higher up in all that radiation. So anyone that's flying, especially like they're a flight attendant or a pilot, they're getting more of this ionizing radiation in general, and then you get this activity. Keep that in mind. Make sure you're really doing what you can to balance your system, stay grounded, calm, cool, collected, and everything. Grow, Gene, anything been released yet on the semi-secret NASA study for 99% of sun's energy already gone? I've never heard of that. Must be really secret NASA study. But yeah, maybe that's something for you to look into. Just in general, if you're watching this, you find that kind of interesting. I've never heard of this before, but it sounds like an interesting rabbit hole. Thank you for showing that with us, Gene. Above the Norm News, thank you for all the work that you do. Thank you for your super thanks. I'll keep at it. And I am Valentina asking, I heard that mass determines consciousness. The two are certainly connected together. But whether it's mass determining consciousness, I would say consciousness is probably more fundamental than mass. But again, they're like super interconnected and linked. And another super thanks here from Bazooka. I think he had Bazooka had one also prior. So welcome, Bazooka. Thank you for your super thanks. Is it plausible that a northern directed flare impact might accelerate the recent series of strong earthquakes close to Reykjavik, possibly leading to an eruption? Well, these flares aren't necessarily directed just to the northern part of Earth. I mean, as a whole, the Earth is very tiny in relation to the space environment and the sun. So when this hits, this is going to hit. Though Iceland is in the Arctic Circle, effectively. And that's where you do get the majority of solar plasma to come down. So I don't think it's a coincidence that we have Iceland there in the first place, which is the boundary between, is a connection between a mid-ocean ridge and a hot spot. That's right there in that zone. You also have the magnetic pole, of course, coming out in the northern hemisphere, and you have a supervolcano, which is another mid-ocean ridge and volcanic caldera that exists right there in the northern hemisphere, the Arctic Circle. So there is this connection between space impacts and the geology and energy flow specific to those areas. So as it relates to Reykjavik, and I know you're talking about the huge amount of magma intrusion that's occurred just off the coast of Reykjavik to the west. This is the smoke spine. Then that's certainly possible. That's going to go regardless at some point soon. Huge buildup in Iceland. We're probably looking at some really big volcanic activity, like perhaps historic volcanic activity from Iceland in months to years. It's already been started, but now there's just this huge new injection. In Baxter, living near Salem, Oregon, not sure how I could prepare. I appreciate you. Yeah, just make sure you have a hand crank radio, flashlights are charged, you have your food, your water, a solar suitcase, things like this, and you have a evacuation preparedness plan for a big earthquake. Because if you do get a big Mag 9, Mag 8, Mag 9 on Cascadia, you're going to want to make sure you go to a safe location, if you can even walk. But you're definitely not going to want to be in a rickety structure. You're going to want to go to a clear open area, right? Or if you are in a rickety structure, run to your desk and take cover. So these things are important to know, and just doing drills every now and then is important. Okay, here's a question from Der Hot in Tot. I can't, yeah. What should people watching tell their elderly or less healthy relatives or friends? I mean, that's kind of difficult because everyone is so, not many people are open to suggestions. And to say, the solar flares are coming, and someone's already smashing cheeseburgers and drinking soda, I don't think they're going to care at all. I don't know really. I would just mention maybe that we have big solar activity coming in and how that affects people energetically, and it makes things more volatile. But I wouldn't necessarily give recommendations because they'll probably fall on flat ears. But certainly you could talk about the connection between solar activity and metabolism, the energy of the earth, the energy of the body. People probably find that interesting, fascinating. Maybe that kickstarts a little bit of a curiosity that leads them to better decisions. Or if they're elderly and you have some ability to influence the outcome, make sure you have them go outside and put their feet on the grass for a little bit, right? That's really the key. Grounding is so important. Yeah, keep them calm. Yeah, that's a great advice from a moderator here. So don't freak them out. Keep them calm. Actually, that may be the best thing. At this point, who cares if you learn something? I mean, I'm always curious. I think I'll always be learning at that age. But for some people, they're like, listen, I'm 90. I don't care. I'm about to go. I don't care. So the best thing you do is with that information, just how you improve the situation in general is probably the smart thing to do. Just keep them calm. You know it's coming in, but don't freak anybody out. Would love your input on the coherent plasma discharge video I sent you about the Mayon eruption, meteor strike, and spirally rising light. Thank you. I'm not sure what this coherent plasma discharge video is. And then as it relates to the eruption at Mayon volcano, that meteor came in, then the plasma orb that came up afterwards, we discussed that. So very interesting. I think it's a perfect example of just weird things that we don't have explanations for. Some people are saying it's a satellite flying over, but I don't know. I don't know this video you're talking about. So thank you for the super thanks, though. I want to take some questions from the general audience because some of these are here. You know, a lot of people are here. I want to make sure I get to some of you guys. And one from Sarky Pants. This was something that was going around a few months ago. It's just some random fake news thing. Probably, I think it started on TikTok, which of course makes sense, about the Earth losing gravity for like 8 seconds in August. It's total bollocks. And if it happens and we're all floating away, then it doesn't matter if I was wrong about that. But it's just one of these fake things that is just made up. So don't worry about that. You know, people now with AI, they can make videos of people floating away and make it look realistic and stuff. So don't worry about dumb stuff like that. Yeah, and Rob Clinton, don't put your feet on grass if you have, you know, fire ants or wasps or ticks or etc. I mean, find a good spot. You can also do feet on concrete. Concrete's still fairly conductive. You can make it more conductive by putting a little bit of salt water on the concrete, letting it soak in a bit. That will greatly increase the conductivity. Then you put your feet on that, and salt water will also help disinfect it too. So there's other ways to ground. It's not just grass or ground, but concrete can also work. Asphalt, though, is very resistive. You're not going to ground on asphalt, okay? Because it's all oil, right? It's very resistive. But concrete can work. Or like hard rock, that's all fine. And a super thanks question from Erica, which is, has entering the photon belt changed our DNA? Well, just to quickly kind of discuss the photon belt, that's not really something that would exist because photons are moving at the speed of light. So if there was, you know, every solar flare is creating a wave of photons that hits us, right? But for there to be like a huge decadal-long, century-long wave of photons, would have to be from some ongoing energetic eruption. It's just continuous. And we would pick that up with our sensors, and we're not picking that up. So it's just a descriptive term, effectively, for entering into a new region of space with different energetic properties, because space does have a cellular structure at multiple scales. It's fractal. At the interplanetary, interstellar, intergalactic scale, there's a cellular structure to space. Meaning that there's areas of low density, areas of high density. Right now we're in what's known as the local bubble. It's an area of hot, low density plasma, and we're entering into a G cloud. It's a different condition where the plasma density is kind of unknown. It's probably going to be a little bit higher and lower temperature. That can affect the overall heliosphere of the sun, the magnetic field, and therefore what's happening here on Earth. So, you know, that transition with the G cloud, the research is indicating that's happening now up to the next 2,000 years. Again, I think that'll probably end up being revised as we learn more. This is all very new data. Then how does that affect our DNA? That's a big unknown, right? There's something there, but the research is basically non-existent. And the reason I say there's something there is because DNA is a fractal antenna. It's highly conductive. Some people think it may even be superconductive, and it has this self-similar design because of how, you know, it's this double helix, and it folds up in such a way to kind of recreate the double helix at different scales. So by having a self-similar design, and it's very, very long, it in fact acts as a fractal antenna, meaning it can connect, and it does connect to a wide range of frequencies. So the energetic background field, and therefore the frequency, the resonance, vibration, everything is changing, our DNA is going to connect to that, and how that affects us is unknown. We know that a tremendous amount of our DNA is not active at any given moment, but it can perhaps become active depending on how the electromagnetic environment influences it. Because we do see that electromagnetic radiation, like Schumann resonances, can cause electrons to move within DNA, altering the resonance of the DNA, and that's what helps attract then messenger RNA to those zones to then generate proteins. And that's been demonstrated with stress proteins. But conceivably, the intercellular electromagnetic field influences the electric voltage gradients of the nucleus in DNA, the nucleus within the cell, and therefore the production of proteins, the synthesis of them, which ones are being produced, how often, how much, etc. So yeah, I think the reason why there's this idea of like the photon belt affecting DNA is that it's just a very simplistic understanding of what actually is unfolding. And since we don't have good data on this, we just label it the photon belt. And well, plasma produces light and light produces plasma. So maybe it's not the worst term. But it's also one of these old things that's been floating around for like 30, 40 years that was just made, was just kind of made up by someone, but there's something to it. Some more super things have come in. Thank you for your super thanks, Dan. Much appreciated. And one of mine, thanks for being such a long-term member. Stick and Stones, thank you for the super thanks. That's awesome. Are we going through a charged area of space? Yeah, I just talked about that. We're in the local hot bubble. Yeah, the plasma density is low, but the temperature on it's high. So yeah, and 99% of the universe is plasma. So this is the majority default state of the universe is plasma. We're kind of the oddballs here on Earth with matter, right? I mean, non-plasma matter, because you have solids, liquids, gases, plasma. So the sun is majority plasma, right? We have plasma within us. The Earth has plasma within it. There's a lot more plasma hanging around in our environment than most people realize. It's not just in space. There's a lot of it here as well. 99% of the universe is plasma. And a phrase that my friend Dana Kippel loves is plasma is the goddess. Yeah, so interesting. If you want to learn more about plasma from a very wide-ranging perspective, especially as it relates to you, then you can check out Dana Kippel. And she's on Instagram. She's on YouTube as well with Plasma Intelligence is her handle, but you can go to Instagram, really. That's where she posts her stuff. And that would be Dana the Alien. You'll see her. She's a bundle of plasma, bundle of sunshine. And a question from How Infinite 8D. Again, how does the solar flare affect the Earth to cause an earthquake? Can you please say it intelligently? Yeah, well, if, maybe we'll find someone even more intelligent to say it. There's a research paper I have from 2020 on the correlation between solar activity and large earthquakes worldwide. And so they examine specifically particle flux, like the relativistic particle flux and big earthquakes, and found a very significant statistical correlation. And they lay out the different ideas as to what could be doing this. There's more than just this idea. There's a reverse piezoelectric effect. There's the charging of the ionosphere and the induction of telluric currents. These are electric currents through the Earth that can, as they pass over a fault, which are generally already more conductive due to the mineral makeup and also due to hydrothermal activity within a fault, because it's a preferential pathway. These salty brines exist. That allows these electric currents to go through, and electric current passing at the molecular level can break apart a molecule and get that electron to get energized, right? Because it's electricity. It can cause ionization. And if you have a breakdown in molecular structure, perhaps that's enough to get the fault to go. And the reverse piezoelectric effect is when there's an electric current passing through something that causes a mechanical deformation. It induces stress mechanically. And well, as we know, a fault is building up stress and strain, and it needs a certain critical threshold to be reached to then rupture. And well, if you're adding on mechanical stress and it's right there at the edge, ready to go, and boom, you overload it, that could cause an earthquake. But they specifically talk about it in this paper. I'm not going to read the paper, but at the end here, they do have a section titled "A Possible Qualitative Model to Explain the Observations." And so let me just read through this for you. The authors of this paper are Vito Marchitelli, Paolo Harabaglia, Claudia Trois, and Giuseppe de Natali. So, a possible qualitative model to explain observations. Once a strong correlation between proton density generated by solar wind and large earthquakes worldwide has been assessed, the next step is to verify if a physical mechanism exists which could explain such a result. Several mechanisms have been proposed till now for solar terrestrial triggering of earthquakes. Although former observations about solar terrestrial triggering were not convincing, this is the authors, right, their words, some of the formerly proposed mechanisms could explain our results, which are on the contrary statistically significant. In particular, piezoelectric effects in rocks generated by large electric currents are interesting. Our observed correlation implies that a high electric potential sometimes occurs between the ionosphere charged by the high proton density generated at higher distances and the Earth. So this is that global electric circuit. The ionosphere typically has a equipotential of 250,000 volts or 250 kV. It's very strong. Earth is 0. In the high latitude regions, that can be enhanced quite a bit to even like 300, 400,000 volts or 400 kV. And as a result, you get a stronger electric gradient between the ionosphere and the crust. And you get this reverse piezoelectric effect where then these electric currents induced in the ground surface induce mechanical strain in that local region. So such a high potential could generate both in a direct way or determining by electrical induction alterations of the normal underground potential and electrical discharge channeled at depth by large faults, which represent preferential highly conductive channels. Such electric current passing through the fault would generate by reverse piezoelectric effect a strain/stress pulse, which added to the fault loading and changing the total Coulomb stress could destabilize the fault, favoring its rupture. The reverse piezoelectric effect would be due in rocks by the quartz minerals abundant in them. Such effect can work in principle for all kinds of faults. The piezoelectric effect, in fact, acts to produce a pulse of dilation or contraction on a particular axis of the crystal depending on the polarity of the electric current. For quartz crystals randomly distributed on a fault surface of any orientation, the net effect is a pulse of strain/stress normal to the fault because the other stress-strain components compensate among them into the bulk rocks. The normal stress can stabilize or destabilize any kind of fault depending on the sign. However, since it is a transient pulse, it has an effect only in case is able to instantaneously increase the total Coulomb stress on a given fault above the fracture strength, thus generating an earthquake. It would then represent only a small destabilizing effect over a already critically loaded fault zone. So the earthquake cycle would be anyway dominated by tectonic phenomena, but this small external triggering could generate the observed slight correlation between correlation among worldwide earthquakes. These kind of effects induced by high electrical potential between the ionosphere and the Earth should likely be accompanied by electrical discharges in the atmosphere, which would cause luminescent phenomena. Actually, there are numerous observations of macroscopic luminescent phenomenon named earthquake lights before and accompanying large earthquakes. And this is accompanied by changes to the ionosphere, these total electron content changes, and we get these earthquake lights to blast up out of the Earth. That's plasma. You get these plasma discharges from the Earth during large earthquakes. You often see radio frequency emissions at Schumann resonances, all the way to VLF, even changes to Earth's magnetic field overall for huge earthquakes like Alaska, magnitude 9.2, 1964. there were these oscillations, long period oscillations that were picked up in Earth's magnetic field from thousands of miles away. So it's all connected together. And more in general, a lot of electromagnetic anomalies, often well evident, are more infrequently reportedly associated to moderate to large earthquakes. So there's a lot happening here. And this paper, specifically looking at data with earthquakes and protons, saw that there is a connection between proton density near the magnetosphere and earthquake activity worldwide. So I'm going to have to call it there because I have something coming up. But thank you all for joining in today on today's video. I'll keep you up to date on everything that's happening. We've had two 1.2 M-class flares, 3.3 M-class flare, 9.3 M-class flare, 7.7 M-class flare, and a 1.0 X-class flare. We are waiting on the impact from this coronal hole high-speed stream. We've had earthquakes just recently pop off in Cascadia, in that zone. So a lot happening right now. I'll keep you up to date on all that and much more. I've been your host, Stefan Burns, geologist, geophysicist, your cosmic bro, here to help you understand what is happening. Smash that thumbs up button, help the channel grow. Please subscribe. Make sure to really pay attention to how you feel, your health and wellness over the next few days as this big mega storm comes in. We're looking at G4, G5 conditions based off of my forecast. At a minimum G3, but based off what we're seeing, G4, G5, and I'm honestly skewing towards the higher end, though it depends on the magnetic field configuration of the solar storm. If it's strongly positive polarity, then it's not going to probably be, it won't be as strong as if it was negative polarity. And the last big extreme storm that we had in January was strongly positive, and so we really got lucky. So this could be a big deal. Satellite problems, GPS failure, power grid changes, like this could be a big deal. So make sure you do what you can to harden up a little bit as well. So thank you all. Have a great day. I'll see you all in the next video.